Hey guys, let's take a look at series and convergence and what does that mean? So first of all, an important application of sequences, which we studied in the last unit, is in representing infinite summations. Summations meaning adding things together, sums. Informally, if you have a sequence, a sub n, and it's an infinite sequence, then this notation right here means the sum of the first term in the sequence plus the second term plus the third, all the way out to the to infinity. So this is called an infinite series, or sometimes it's just called a series. These numbers, a sub 1, a sub 2, a sub 3, are called the terms of the series. And notice in this, sometimes we're going to want to start with n equals 0 or some other integer depending on the situation at hand. So just keep that in mind, that that is also a possibility, and that means you would have, if you start with n equals 0, then you put 0 in for n to get the first term, and then 1 in to get the second term, and so on. So partial sums, we're going to be looking at partial sums, which means not going out to necessarily infinity, but if you find the sum of the first term, it would just be finding a sub 1, just the first term. And then s sub 2 means, add together the first two terms. S sub 3 means add together the first three terms. Those are called partial sums because we're not going all the way out to infinity. S sub n means find the sum of the first n terms, and we can put in anything for n. So we're going to represent that with dots to indicate that I don't know how many terms I'm adding because I don't know what n is. But you would add up to the nth term. And so here's a big thing, big topic or big concept for this unit. If the sequence of partial sums converges, the series also converges. So this is a main topic here that we're going to be discussing in this unit. Okay, so in your notes, put this definition in to your notes. It's on page 608 in your textbook. For the infinite series, of a sub n from n equals 1 to infinity, the nth partial sum is given by this, and it'll be represented with s sub n. And so if we wanted, so we'd find s sub 3, it means add the first three terms, and so on, like I just showed you. If the sequence of partial sums converges to a number s, then the series also converges. So if the sequence of partial sums converges to s, then the series converges as well. The limit s is called the sum of the series, and then conversely, if s of n diverges, if the sum of the first n terms is diverging, then the series diverges. So let's take a look at some series. So in example A, you have 0.1 plus 0.01 plus 0.001 plus etc. 0.0001, adding or multiplying by a tenth each time is what's happening. What's going to happen to this partial sum? Is it going to start converging to a single number, or is it diverging and just getting bigger and bigger, or not going towards a specific number? And if you think about this, if I add these up, I have 0.1 plus 0.01 is going to equal, so the sum, so s of 2 is equal to 0.11. S sub 3 is the sum of the first three terms. We already have the first two terms added together, so I can just tack on the third term here. And if you line up your decimals, you're going to end up with 0.111. S sub 4 is going to be the sum of the first three terms plus the fourth term. And let's see, we have 3 zeros and a 1. If you line up your decimals and add, you're going to get 0.1111. So we can, if we take this out to infinity, what's going to happen? Well, let's go to s of n. S of n is going to be 0.1111 n ones. I'm going to have a list of n ones here. And if you go out to infinity, well, right here, I could keep going, but I'm going to end up with the sum of the first n terms is equal to, it's converging upon 0.1 repeating. So therefore, the series converges, and it converges to 0.1 repeating. So look at B. Think about B, what the sum of the series, the first two terms would be. If you have 3/10 plus 3/100 plus 3/1000 plus 3/10,000, what happens? If you think about it, this is really the same thing as the series above, except for instead of 0.1, 3/10 is the same thing as 0.3, and then 3/100 is 0.03, and we have an extra 0 in there each time. This is going to converge, and if you line up all your decimals and start adding this, it's going to be 0.3, 0.33333, and it's going to end up being 0.3 repeating as you add the entire sum from the first term to the infinite term. All right, look at C, and why don't you try to figure out what you think. Is the sum going to converge, or is it going to diverge? And pause the video, think about it on your own, and then let's come back to it. All right, so we have 1 plus a half plus a fourth plus 1/8 plus 1/16. If you start to add these terms together, let's find a common denominator. Let's add the first 1, 2, 3, 4, 5 terms. So what I'm going to do is make my denominator, I'm going to find s of 5. Well, you know what, let's just start with s of 1. So we have s of 1 is 1. S of 2 is 1 plus 1/2, or 1.5. S sub 3, the first 3 terms, is 1.5 plus 0.25. I'm just working in decimals just because it's instead of finding a common denominator, but I'm going to do that in a minute. So I have 1.75, because I'm adding 1/4 to that. And then S sub the next term, let's look at this as fractions, and let's add, doing 1/8 and 1/16 in my head is going to get harder. So I'm going to do 16/16. I'm going to add these first 4 terms together. And then this is going to be, I have to multiply by 8, so 8/16. And here I have to multiply by 4, and then by 2. And adding all of these together will give me S sub 5. And for S sub, my denominator will be 16, and the numerator is 16 plus 8. You've got 24, 28, 29, 30, 30, 31. 31 over 16 is approaching a number. And if you look at this, we started out with 1. S sub 1 was 1. S sub 2 is 1.5. S sub 3 is 1.75. 31 over 16, I'm grabbing my calculator here. 31 divided by 16 is 0.19. So this is S sub 5. I didn't find S sub 4, but I'm going to go S sub 5, and then we're going to see if we can determine if this is converging or diverging. So this is 1.9375. So I'm adding smaller and smaller fractions every time. However, I'm still adding to it, but I'm adding just a tiny bit. And if we look at the 6th term, let's just keep going here. It's going to be this 1.9375 plus 1 over 32. And so I'm just using my calculator and adding that together. And it's this is equal to 1.96875. It looks like the decimal in the tens place isn't changing, but now the hundreds place is changing. So it looks like it's converging, and it looks like to me like it's converging upon the number 2. We haven't proved that, but it's just the pattern looks like that's what's happening. Okay, so why don't you guys try this one on your own, see if you can figure out if it's converging or diverging, and what is it converging to if it's converging. So if I write these as decimals, the first term is 0.15, the second term is 0.0015. Notice that, okay, we had 2 zeros here. This is how I was thinking about it. I'm adding 2 more zeros, which moves the decimal over 2 places. So 0.15 plus 0.0015, the sum of the first 2 terms would be 0.1515 if you line up those decimals. And then the sum of the first 3 terms is going to be s of 2 plus this third term here, so I'm adding this at the end. The first first 4 numbers after the decimal are zeros, and I'm adding this to it, so it would be 0.151515. And if you continue this on, you're going to end up with the sum of the series equal to 0.15 repeating. Okay, so we're going to look at one more thing here. The series. Does this series converge or diverge? So we're going to look at the partial sum. Okay, so the sum of the first term is 1/2, and then it's 3/4, 7/8, 15/16. If you follow that pattern, the numerator is always 1 less than the denominator. So the nth term would be 2n minus 1 over 2n, and because the limit of that is equal to 1, it follows that the sum of this series is equal to 1. And if you look at this visually, if you take a square and then we fill in half of the square here, and then so that's S1, it's 1/2. S2 we have 1/2 plus 1/4, and then we keep adding half of the remaining part of the square, so that's 1/2 plus 1/4 plus an 1/8, and then plus a 16th, plus a 32nd. And then if you keep this continuum on, you have a tiny little space in that upper right-hand corner, which you can barely even see. You can see that visually this is going to add to, the sum of the series will add to 1. Likewise, let's look at this series. You have from n equals 1 to infinity of 1 over 4 to the n. So same thing, if I fill in a square, I take 1/4, that's the sum of my first term. S of 2 would be 1/4 plus a fourth of the remain of another square, and then taking this upper square here and taking a fourth of that, etc. You keep doing that infinitely. What ends up happening is if you translate all of these over, you can see that this is 1/3. We have 3 boxes that are the same, one of them is filled in. Same thing here, we have 2 boxes not filled in and 1 box filled in, all the same size boxes. Uh-oh, my computer's acting up. And same thing here, so 2 of the 3 are not filled in, 1/3 is filled in, so the sum of this series would add to 1/3. We'll look at this in a more analytical way in the next video. All right, see you.